Hello everyone, my name is Uladzislau. I'm a DevOps engineer with a little over a decade of experience in the tech. Oh, okay. Hello everyone. Sorry, I need to start again. So my name is Uladzislau. I'm a DevOps engineer with a decade of experience in the tech field. I built architecture for various startups and worked in various enterprise projects. And today I want to share you a bit more of inside information, what's happening with the GitHub infrastructure, GitHub workflows, self-hosted runners, GitHub runners, what problems we are facing and probably you're facing with the runners, how they're provisioning, what's on the market for automation of provisioning self-hosted runners, what self-hosted runners means and why they're important. So let's dive in. Here's the agenda. But yeah, I described it in short already. So before we start, I just need a little bit insight from you to be sure how deep I need to dive in some topics. So raise your hands who worked with the GitHub Actions, GitHub infrastructure. Okay. Now raise your hand if you're working with the self-hosted runners. Okay. And raise your hand if you worked with the action runner controller to provision those runners. Yeah. Okay. Now we're getting somewhere. Okay, let's go. Okay, for those who did not work with GitHub runners, here is a source version control called GitHub. They have a declarative YAML pipeline language for provisioning for CI/CD. And runners, it's an agent for those pipelines that run this arbitrary code. It's literally a binary that can be installed on anything. There's two types of runners, self-hosted and GitHub provisioned. Yeah, so how they are working. So we have the pipeline, just a simple YAML file, build that, deploy that, build that when a pull request is created or manual workflow is triggered. Then it sends an event to the GitHub. GitHub picks up that event, create a job, then looks at a label. If then runner constantly pulls labels for those actions. If job is created with specific labels that self-hosted runner or GitHub runner match, it immediately picks it up and starts to work first in, first out. So that's the kind of flow here. And a couple of differences. So what are GitHub runners? GitHub runners, it's some sort of virtual machines, Docker containers that run on GitHub infrastructure. They control environment where agents is installed. They're good, they're pretty fast at picking up jobs. They have decent capacity. And if you want more, they have even so-called large runners for heavy lifting. Yeah, what they lack of is your control. You cannot plug in your specific hardware, CAN buses, GPUs, APUs to that. So if you're requiring any hardware development, embedded development, you definitely need a self-hosted runner if you want to continue to use GitHub Action infrastructure, yeah. And networking, especially with deployments, there is a lot of constraints to use GitHub provisioned runners for deployments because they're in a GitHub network. So they are not connected directly to your network. And if you're not exposing endpoints or poking holes with VPN, you cannot reach your endpoints for deployment. And usually those endpoints pretty meant to be protected. Yeah. So that's why we are using the self-hosted runners. to be able to be in control, to be able to be responsible for security, to be able to reach out our internal networks, to be able to use not virtual machines, but physical machines for some needs, to be able to pass through GPUs, etc. Yeah, and especially because if you have a lot of jobs, you simply don't want to pay to GitHub if you have a lot of infrastructure laying around doing nothing. Imagine you have a data center, your on-premise organization, you have a lot of virtual machines and you simply don't use them. And you spend all your quota of GitHub for GitHub runners. Why? When you can just use your own infrastructure. And the common struggle here is, how can I provision those infrastructure automatically? I mean, for GitHub runners, it's plain simple. They are already there. They are auto-scaling. They have their own code infrastructure for that. You don't control it. You just send it in and it's picked up. For you, GitHub does not expose pretty useful mechanisms to be able to register runners. You have two ways to know that your job needs some sort of self-hosted runners. First one is constantly fetching API across all of your organizational repositories and see if any job is requested, which is exceed your API quota pretty fast. Second way is to use a webhook. So GitHub sends to your endpoint a payload with all needed information. You process this payload and you create a runner yourself with automation. What's the problem with that? The problem currently, the only pretty decent solution for that is Action Runner Controller, which is heavily tied to Kubernetes and OpenShift. And as we already established, not everybody who uses self-hosted runners use Kubernetes. So what we're doing, we're usually writing our own automation for that, writing our own controllers. Everybody writing their own controls and nobody shares the controllers. There's no pretty much solution on the market. And you might object to that and say that, well, I just can install Kubernetes and use containers. Trust me, that's a bad idea. It's never just a Kubernetes. If you're working with Kubernetes and you just need one application, trust me, you don't just need one application. You need ingress controller, networking, you need load balancers, you need network rules, or you need multiple Kubernetes instances if you have multiple environments. And it goes down the spiral. And imagine your application does not containerized and does not use Kubernetes. Maybe you're stuck with ECS. Maybe you're using Amazon solutions. Maybe you use plain virtual machines or just Docker Swarm. That happens, and you still need the runners to build your code. So you're actually stuck with two choices currently. Well, actually, four. The only repositories that I'm able to find is for EC2, provisioning on demand with webhooks, and some self-baked Azure automation for the VMs. So, or bake your own code. So the question is, what we're going to do about it? So let's circle back and see how things work on the side of infrastructure as a code. We have those awesome tools for provisioning: Ansible, Terraform, Terragram. What they have in common, they are modular. So you can plug in only what you need. They have communities around this. Those modules are pretty not bloated. They're minimalistic. They are supported by the community. And what I'm suggesting is to stop this mess, stop building controllers by yourself, and collaborate, build something together. So, okay, so that's what I'm currently working on. So I created this Python project, and before you ask why Python, because come on, 90% of the DevOps uses Python for automation. Prove me wrong in the question section. Nobody uses Golang, nobody uses Node.js if they had to. Only if they don't have a choice. It's mostly Python. So I choose whatever people use the most and whatever I am most familiar with. So what's the approach here? This application is just a plain controller that process payloads, webhooks from the GitHub. It just uses a Flask application, serve the webhook processor. It gets a payload from the GitHub, parse the event, and send it based on what label are requested and configure it on controllers. GitHub has those awesome labels that you can tell which runners should be used for the job or should pick up the job. Yeah, and based on that, it talks to so-called provider. It's an abstraction just for another Python piece of Python code that provisions runner for you in any way possible. It can be virtual machine, it can be container, it can be whatever you build it. The idea here is to use modular approach as a Terraform use, as Vagrant use, as Ansible, to have those building blocks that we can build them by ourselves and share and use the common controller and common coding patterns. So we can finally solve this issue of not having provisioner of your choice. Okay, so here's a simple example. So you have the GitHub webhook. It comes to the controller. It looks what provider you want to use. For example, you have a bunch of Hyper-V machines, and you just call them with a PowerShell usually. And you get the template of provider that I baked. You just send those PowerShell scripts inside the function that creates runner. And you add a post script to the runner to kill it. Currently it works only on demand, which is optimal in my opinion. Yeah. Or you can use EC2 for provisioning those VMs. Or you can use whatever you like. That's the point. You bake the provider, you send it, you share with others. Not only you maintaining, community maintaining it, everybody's happy. And you just call it a day. You don't have to constantly rewrite controllers when you switch to projects or choose a different type of runners eventually. So in my opinion, it's a good way to solve the problem. If you're interested in how you can help, you can just scan this QR code, start this project, and wait for the updates. It's in development, heavy development currently. It has a structure, it has a webhook processing unit. It has a template that works with a plain Docker. You can take a look, you can fork it. It has MIT license, so feel free to fork it. You use it whatever you like. Yeah. Yeah, and here's a short meme. Why we need that. Okay, I think that's pretty much it. Any questions? Come on, don't be shy. Show it.
I've got a question. So how many instances did you spawn with this tool?
I don't load test it, to be honest, but I spawned like 20 containers. It pretty much works. And here's the thing, because you're working with the webhooks and controller is a separate entity that accepts RPC requests, you can scale it. it doesn't require to have a leader because it's not provisioning in advance any runner. So you can scale this Flask application on how many instances you like. It can be multiple containers, for example.
Okay, another question. Did you hit, for example, API limits when you try to spawn pods and so on, or runners?
I personally did not, but it's totally possible. And the thing is about API limits, it's per external IP address, for organization, I believe about 5,000 or something. And I probably won't hit API limit because I really need one API call just to get a token. And when the GitHub agent makes a call, it doesn't count to your API rate limit when the GitHub agent registers. So it's only your API calls to register runner. And webhook is outcoming connection.
Another one, do you have any metrics for this application to see how it behaves?
No, as I said, it's heavily development, in heavy development.
Can you be more on the stage, please?
Oh, of course, okay. I'm just a bit shy person. Yeah, sorry to disappoint. As I mentioned, I suddenly find out that it requires a lot of coding. That's why I shared this problem with you, and if you're interested, feel free to contribute, because I believe this is important and we don't have to be in our own islands, writing our own codes, reinvent the wheel many times, when we can collaborate and finally solve this problem for good.
Yeah, maybe I will share just how I solved it partially for my place. I use a funny approach where GitHub hosted runner is just starting my on-premises or creating on-premises resources. So yeah, such tool could be interesting. That's interesting. I was also wondering whether you have or not any like funny stories or interesting advices or from your experience with use of GitHub Actions, CI/CD in general in your clients or endeavors.
Yeah, I have a good one. I had a client that needs to work with 3D vector calculation for industrial equipment. So it calculates heats, resistance, etc. And it requires a lot of OpenGL. And the thing is, the test needs to be run on self-hosted runners, and there is no built-in OpenGL support. I suddenly find out that there is software OpenGL support, and I don't need any hardware. The second fun thing about that I actually was able to hit API limit when I used Action Runner controller with one of our customer, because fun thing, ARC actually retries to re-register runners even if it does not have correct credentials, and I just hit API limit.
So I wonder how the feedback from a running task is handled with your approach.
Yeah, so there is actually no feedback. So the thing how, for example, in Action Runner controller, the controller works. The runner controller in Kubernetes, for example, it checks for the pods. If pods finish the work and idling, it just kills it. But the GitHub doesn't give any tools for sending an event that job is finished, so the runner would idling. What I am doing, I am just using this awesome ability of GitHub agent that you actually allow to execute any shell, bash, PowerShell scripts post the job. So the job is finished, I just type the script to shut down the container within it or the VM within it. And that's how I solve this issue. because I really need to have those resources provisioned only where the job is requested. I don't need those in post sitting idle, and that's whole the point of on demand. Yes.
Thank you.
Hi, great presentation. Can you compare the GitHub runners self-hosted of your solution with that GitHub runners on the GitHub side? What is the performance? What is the cost? And etc.
No, I did not. However, those comparisons are already in the wild, in the web, and to be honest, with 90% of the work cases when you don't constrain with the networks, use GitHub runners is cheaper. They're paid by the hours, and if you write a pretty good, decent pipeline with caching, it has fast network. So there is not a lot of computation if you're not doing testing. If you're just building software, deploying software, GitHub runners is a way to go. However, it's a tricky to get, for example, VPN tunneling. So we're using self-hosted runners mostly because of networking in 90% cases, and the 10% cases is when you have to have specific environment. Sorry, large runners are expensive though, but they are worth it for those who build, for example, monolithic applications in enterprise large scale, because there can be compute heavy.
Are you told that you have some demo also?
Yeah, guys, if you are interested, I can share the code. However, in this environment, I can't expose any webhooks, so I have to manually call the RPC procedure, and I mostly can share how the code looks, so what's approach here. Or you can check it by the QR code if you feel like it. So raise your hands if you want to see the code. Okay?
Don't ask.
Okay, I'll share it. No worries. One moment. Okay, let's start with a simple one. Let's start with provider itself, so-called provider. It's just a fancy word for abstraction for the service. So it's actually plain simple. It's that simple. So what we have in the main, we have this RPC server. I used RPYC because it has those fancy exposed methods, and I'm planning to connect doc strings, so when you're developing something in a controller, it just hints you what's in the provider template. Then you just start the server. This port currently is hard-coded for demonstration purposes, but it's picked up from environment variable. Yeah, and this is plain example of the provider. It's so simple, it's just stupid. Look at it. So it's a exposed method for RPYC with some GitHub credentials, labels, organization, and for the demonstration purposes, the command is simple here. You just call the Docker. But as I said, the cool thing is you can wrap it around however you like, because it's template, and you can post AWS, anything. And once it's in the wild and it's there, we have the centralized controller that we can plug in those multiple providers. And the cool thing is I purposely chose to use RPC to be able to connect this via Unix sockets or TCP sockets. So you can use the Unix sockets and work within one hardware, or you can use TCP sockets, for example, if you don't want to expose anything in your production network, don't want any potentially vulnerable web servers spinning around, you can have this somewhere else and just connect to that tunnel with a TCP socket. Yes, that one with a TCP socket, and it would be pretty secure. And in this example, I just run as a simple Docker runner plain and simple, doesn't require any Kubernetes installation, can be run locally, can be run in container anywhere. Before we switch into the controller side, where things get a bit complicated for no reason, do you have any questions maybe about this code? Why, what, where, what's the plans in the future for this? Anybody?
No.
Okay, we can move on. I just assume that everything is clear here, so... Okay, here we go. So, the controller. Let's start with a small the main function that's called. It's actually purposely built with a PyProject TOML because I eventually planned to be able to compile it into the binary. Because running Python code directly, somebody can consider this cringe. I like it. Okay, and as I mentioned, there is a lot of hardware for demonstration purposes, but what it's do, it's load the config from the environment variable and YAML file, set login level, and start Flask application. For the configuration, we have this fancy structure. It's pretty plain and simple, just data class is information that get loads. Then we have the provider class, which is for providers. You can describe them in this object manner in a YAML file. It's a provider, TCP socket port or Unix socket port, it would be parsed. And labels that has to be directed to the provider, because if you want to have multiple providers and choose labeling for them, for matching labels, you can customize that. Obviously, you will need that. And the provider, so just get this information, connects to the RPC. It has this expose method to get GitHub runner, and it returns login information, is it successful or not. Actually, the fun thing about the controller is just process the request and direct things. It doesn't need to do anything more fancy rather than wisely choose the correct provider. So we don't need to do much here. The backend of the provider would figure it out. So no complex logic. And it serves the simple post webhook request for processing the event for workflow run. It parses the provider. You send the labels, it figures out which provider it belongs to, and request a runner. Runner is requested. You don't need to do anything much. All magic happens on the GitHub side once this provider with once this runner with correct labels is registered. It would bug the GitHub. Do I have anything? Do I have anything? Do I have anything? And pick it up the job if it matched the labels that it serves. So yeah, that's pretty much the code. Plain simple and scalable. And because it works on the demand using the webhooks, I can pretty much scale how many instances of this Python code I want. And it doesn't require to constantly keep a live RPC connection with the provider. And you can set up alerting, for example, if provider says, hey, I can't register the runner, I am erroring out, it would respond to the controller in RPC, and you can set up alerting for that in your monitoring system of your choice. Questions? Thoughts, suggestions? Maybe something you want to see in this project in the future, something you would like, or something you want to change in this approach, or you want to ask. Anything, feel free.